So, previously we looked at linear applications. For today we're going to look at rational applications. Fractions, right? Word problems that turn into fractions. With today's we're going to look at work rate. And of course, the most famous work rate problem of them all is the painters. A painter can finish a house in 4 hours. Her assistant takes 6 hours to finish the same job. How long would it take for them to paint the house together? Our work formula is the work equals the rate times time. So how fast you can paint the house multiplied by how long it takes you to paint the house equals your work. So rate per time. So the first painter, we're going to call painter A, can paint the house in 4 hours. So we're going to say that's 1 over 4. She can do one job in 4 hours. Now time, this is about time together. So we don't know, so we're going to call that X. Painter B, we know, takes 6 hours to paint the house. So again, painter B could do one job in 6 hours. So 1 over 6. And likewise, we don't know the time it takes for them to do it together. So to find our work, we multiply our rate with our time. So that's X times 1/4, so that's X over 4. And X times 1/6 is X over 6. So the work with painter A is X over 4. The work with painter B is X over 6. Note that they both have X in the numerator, and where we put the how fast they can do the job is in the denominator. So this is pretty much standard. This will stay the same. Now, are they working together, or are they working against each other? Is one painting the house and the other one using paint remover? No, they're painting it together. So what would you think I would do with these numbers here? What does it mean in math, putting things together? Add. Very good. So, take these together and add them together. So I have my work rate with painter A. I'm going to add that. They're working together with my work rate of painter B, and they're doing one job. So this fraction plus this fraction equals a 1. Together they're going to do one house, right? So here's our rational equation. X over 4 plus X over 6 equals 1. How would you solve this? How would you bring these two fractions together? What's the first thing you need to do?
Common denominator.
Very good. Common denominator. So X over 4 plus X over 6 equals 1. My common denominator, let's just multiply these together. So 4 times 6 is 24. So I want this to be a 24. Oops. So I need to multiply 4 by 6, which means I need to multiply the top by 6. That gives me my 6x. Likewise, I'm multiplying 6 by 4 to get 24, so I have to multiply the top by 4. X times 4 is 4x. And again, don't forget about your 1. That has to be a fraction too. So it's 1 over 1. Need to multiply that by 24. Need to multiply the top by 24. So 6x over 24 plus 4x over 24 equals 24 over 24. Now that they have the common denominator, I can add them together, correct? So 6x plus 4x is a 10x over 24 equals 24 over 24. And notice, I want these to be equal, correct? Because I have this equal sign. I want this to be true. The denominators, are they equal? They're equal. So if the denominators are already equal, let's just forget about them. We don't have to worry about them because we know it's true on the denominator. So focusing only on the numerator, I have 10x equals 24 and solve for x. Now it becomes a linear equation. How would you solve for x? What's the opposite of multiplying by 10? Divided by 10. And I get x equals 24 over 10, which of course simplifies to 12 over 5 hours, which as a fraction is 2.4. So roughly 2.4 hours it takes for painter A and painter B together to do the same job. Now, here's how you would set this up. You'll see this problem a lot, SAT, GRE. Let's see if we can find a quick and easy formula to solve these problems. Let's go back to x equals 24 over 10, my answer, before I simplify it. What do you notice about my values here in this word problem to get these numbers? I have 4 hours and 6 hours. How do you get the 24?
You multiply.
You multiply. I have 4 hours and 6 hours. What do you do to those numbers to get 10? Add them. So that's all you have to do, really. is take your work rate, multiply by the work rate of the second one to get the numerator. Take your work rate, add it to the work rate of the second to get your denominator. That's it. So to solve these problems, working together, take your two work rates, multiply for the numerator, add for the denominator. So Principal Hecker can break up a fight in about 50 seconds. Coach Roger can break up the same fight in 20 seconds. How long would it take them to break up the fight together? Well, we're not going to go into there. We're going to try to do some math here. So, again, I said multiply the top two rates, add the top two rates in the denominator. So on the numerator here, I'm going to take 50, multiply it by 20. And on the denominator, what am I doing with these two numbers? I'm adding it. That's their work rate formula. Pretty easy, right? So 50 times 20. Is that 10,000? Somebody check my math real quick. Is that too many zeros? Oh, it's only 1,000. I know. So I get 1,000 on the top, and on the bottom I get 70. Simplify gives me 100 over 70. Which, how many seconds will it take Hecker and Coach Rogers to break up a fight? What's that? Oh, 7, you're right. 100 over 7. It takes 14.3 seconds for both Coach Rogers and Principal Hecker to break up a fight. Of course, not realistic. That's a relatively long time, especially for a fight. But, hey, it's a math problem. So work rate. When you see working together, take your two numbers. For the numerator, multiply top. For the denominator, add those two numbers. Now, let's look at working against. The boat is sinking. It takes the sailor 30 minutes to shovel water out of the boat. At the same time, the hole in the boat is working against them and can fill the boat in 55 minutes. How long would it take the sailor to completely empty out the boat? So is the water working with him? No, it's working against him. Working together, notice we're adding on the bottom. Working against, what am I doing? Subtracting. So, x equals, what two numbers am I multiplying on the top? 55. Very good, 55 times 30. And what am I doing on the bottom? Subtracting. What should I subtract? 55 and 30. 55 minus 30. So on the top, I have 55 times 30 is 1,650 over 55 minus 30, 25. And if I were to divide and simplify, I get 66 minutes. So if there was no hole in the boat, and his boat was completely filled with water, it took him 30 minutes. But since the hole is working against him, it's filling the boat up as he's emptying it, it takes him 66 minutes now. Now note, if you had flipped these numbers, you would have gotten 30 minus 55, you would have gotten a negative. Would it make sense if it takes him a negative 66 minutes? So watch out for that. Because I know he can empty out faster than the water can refill, right? If this was flip-flopped, if it took him 55 minutes here, and it only took 30 minutes for the boat to sink, then you would see a negative, right? Because it's filling up faster than he can empty. So that's the only thing to watch out with these working against, is to see where does the negative happen? Who is actually winning and working against problems?